Okay, students, let's get started with the past papers for space physics. In which region of the electromagnetic spectrum does the sun radiate the most energy? So, sun radiate energy in three rays: ultraviolet, visible light, and infrared. And sun emits the most energy in which radiation in terms of infrared radiation? Any answers like that? A is your answer. Let's further move ahead. Okay, let's see this question. Four stages of the life cycle of a star until it becomes a red giant are shown. Inward force of gravitation attraction is balanced by an outward force from the center. This is known as what? Main. Internal gravitational force collapse produce an increase in temperature. This is the first or the second step in the stages of a protostar. The star expands, most of the hydrogen has been converted into helium. So basically, the first step should be your X. The first step should be your X. Inward gravitational collapse produces an increase in temperature. So A and B will get cancelled out right off the bat. Now, once your temperature increases, fusion reaction will start to happen, and inward force of gravitation will be equal to an outward force. After X, you should have W. After W, fusion reaction keeps on happening and most of the hydrogen gets converted into helium. So after W, your stage should be Z. X, W, Z, Y, D is your answer. Let's further move ahead. What is the first stage in the life cycle of a star? A cloud of dust and gas comes together. Let's further move ahead. What is the definition of redshift? Redshift is basically what? Increase in the observed wavelength of light from galaxies that are moving away from Earth. B is your answer. Let's further move ahead. Okay, let's look at this question. When observed on the Earth, the redshift of the light from galaxy X is smaller than the redshift of the light from galaxy Y. Let's say this is your Earth. Now you know that the redshift from galaxy X is smaller than the redshift of light from galaxy Y. You know that the redshift of galaxy X is smaller than the redshift of galaxy Y. That means the galaxy X will be closer. The closer you are to the Earth, the lesser will be your redshift. So galaxy X is closer to the Earth. C and D options will get cancelled out. Secondly, the more further away your galaxy is, why is your galaxy that is further away from the Earth? The more further away your galaxy is, the faster will be your speed of recession. So B is your answer. Why? Because X is closer to the Earth, because X has a lesser redshift. And since Y is far away from the Earth, it will have a faster speed of recession. B is your answer. Let's move ahead. Which statement is correct? The orbital speed of the Earth around the Sun is this. No, this should have been the average radius. Then it would have been correct. The orbit of the Earth around the Sun is an ellipse. B is the correct answer. Let's move ahead. Which list shows the planets in order of increasing distance from the Sun? Venus, Mercury, Earth? No. Mercury should come first, then Venus should come, then Earth, Mars, Jupiter, Saturn, Uranus, Neptune. C is your answer. I would advise you guys to learn this list. I will advise you guys to learn this list. Let's further move ahead. A student spills ink on the page in a textbook that defines redshift. Perfect. The ink covers the three important words 1, 2, and 3. Redshift is what? Redshift is the increase in observed wavelength. So, increase and wavelength of electromagnetic radiations emitted from receding stars and galaxies that are moving away from Earth. C is your answer. If your galaxy is moving away from Earth and there is an increase in wavelength, then that is known as redshift. C is your answer. Let's move ahead. A student writes four statements about the solar system. Light approximately takes 3 into 10 raised to the power of 8 seconds to travel from the sun to Earth. No. The Earth takes approximately 24 4 hours to rotate on its axis once. Yes, that's correct. The moon takes 1 month to orbit around the earth. Yes, that's also correct. 2 and 3 are correct. C is your option. Let's further move ahead. What is never formed by the explosion of a red supergiant? Okay, what is never formed by the explosion of a red supergiant? A black hole? No, it is formed. A neutron star is also formed. A white dwarf is never formed through a red supergiant. A white dwarf forms through what? Through a red giant star. Let's further move ahead. Let's zoom in here. Let's move on to the theory questions now. Table 1.1 shows details about 8 planets in the solar system, their average distance from the sun, their orbital period, and their average surface temperatures. Perfect. Complete table 1.1 by adding the names of the 3 planets that are not given. Okay, you have to add the names of the planet that are not given. First of all, the closest planet to the Earth is Mercury. Then, between Mars and Saturn, what do we have? Jupiter. And between Saturn and Neptune, what do we have? Uranus. Also, you can check these answers with the marking scheme that is attached right besides the question itself. Let's move on to the question again. Calculate the orbital speed of Mars as it travels around the Sun. So now you have to calculate the orbital speed. What is the formula of orbital speed? 2 pi r divided by the time period. Okay. What is r? R is the orbital distance. R is the orbital distance. What is the orbital distance between Mars and the Sun? This 2.3 into 10 raised to the power of 8. So let's place it here. 2 pi into the distance of 2.3 into 10 raised to the power of 8. Now, here I have to focus on one thing. The distances are in kilometers. The distances are in kilometers, and if this was a normal question, I would have multiplied it by 10 raised to the power of 3 to convert kilometers into meters. But here I wouldn't do this. Why? Because I have to give my final answer in kilometers. So I will keep my distance in terms of kilometers only. I will not convert it into meters. Okay. What is your orbital period? What is your orbital period T? If you see here, yeah, this is your orbital period 5.9 into 10 raised to the power of 7 divided 5.9 into 10 raised to the power of 7. Let's calculate the orbital speed. 2 pi into 2.3 into 10 raised to the power of 8 divided by 5.9 into 10 raised to the power of 7. The answer comes out to be 24.5. The answer comes out to be 24.5 kilometers per second. Describe the relationship between the distance of a planet from the sun and its orbital speed. Let's examine that. So, as the distance from the sun is increasing, what is happening to the orbital speed? Yeah, orbital speed or orbital period? Orbital period, yeah. As the distance from the sun is increasing, what is happening to the orbital period? The orbital period is also increasing. Simple as that. As the distance, as the distance of a planet, of a planet from the sun, from the sun increases, the orbital period increases as well. The orbital period increases as well. Perfect. Nothing complicated. Let's further move ahead. Describe the relationship between the distance from the sun and the average surface temperature of a planet. In your description, include any anomalies. Okay, so what are anomalies? Let's first of all discuss this. What are these anomalies? What is this difficult English word? Anomalies. Anomalies are data set or data value that doesn't follow the trend, that doesn't follow follow the trend. Now, if you examine, as the distance from the sun is increasing, the surface temperature is decreasing. As the distance from the sun is increasing, the surface temperature is decreasing. And can you see any anomaly here? Can you spot any anomaly here? Yes. The anomaly here is this: Venus. As you are going from Mercury to Venus, your distance increases and your temperature also increases. That is an anomaly. So we will write this as well. How will you phrase your answer? You will say, as distance from the sun increases, surface temperature decreases. Surface temperature decreases. Perfect. And as surface temperature decreases, you don't have to give an explanation, right? No, you don't have to give an explanation, but you have to tell an anomaly. So you can say planet Venus is an anomaly. The planet Venus is an anomaly as distance increases, temperature also increases, which is against the trend. Which is against the trend. Let's further move ahead. Let's check the marking scheme as well. Yeah. We have Venus as an anomaly, further from the distance, cooler the planet. Simple. Let's move on to the next question. Astronomical distances are measured in light years. State what is meant by a light year. The distance traveled traveled by light, the distance traveled by light in 1 year is known as your light year. The sun is one star in the Milky Way galaxy. State the approximate diameter of the Milky Way galaxy. The diameter of Milky Way galaxy is what? 100,000 light years. There are several stages in the life cycle of a star. Perfect. Complete figure 10.1 to show the stages that a massive star goes through after it has used up most of the hydrogen at the center of the star. Perfect. So, what will happen if you have used most of the hydrogen at the center? This becomes a red supergiant. Perfect. A red supergiant explodes into a supernova when the hydrogen finishes. This supernova gets divided into two parts. What are those two parts? Nebula and a black hole or neutron star. Simple as that, nothing complicated here. Let's further move ahead. State the region in the life cycle of a star where heavy elements are produced, supernova. Always remember, heavy elements or heavy metals are produced in supernova. Current scientific understanding is that the universe began 14 billion years ago in an event known as Big Bang. Perfect. Explain one observation that supports the Big Bang theory. A redshift of light coming from galaxies moving away from Earth supports the Big Bang theory. The further away the galaxy is, the greater is the speed of recession. The further away the galaxy is, the greater is the speed of recession. Hence a greater redshift. Hence a greater redshift. And if you have a greater redshift going back in time, all stars and galaxies would have been close together. See, the redshift in light explains Big Bang or supports Big Bang. How? Because the further away the galaxies are, the greater is the redshift. Hence, going back in time, all the stars or galaxies would have been together. This explains that the universe began an event known as Big Bang, and the universe has been expanding ever since. This explains that the universe began in an event known as Big Bang, and it has been expanding ever since. Let's further move ahead. The planet Venus orbits the sun at a constant speed of this and takes time TV to complete one orbit. Venus is always 1.1 into 10 raised to the power 11 meters from the sun. Calculate TV. So again, we will apply the formula of orbital speed 2 pi r divided by t. What is your velocity? 3.5. What is your radius? 1.1 into 10 raised to the power of 11. Can you calculate the time period? Yes. Time is equals to 2 pi into the radius, that is 1.1 into 10 raised to the power of 11, divided by the velocity, that is 3.5 into 10 raised to the power of 4. What does your time period come out to be? Let's calculate 2, 2 pi into 1.1 into 10 raised to the power of 11 divided by 3.5 into 10 raised to the power of 4. This comes out to be 1.9. This comes out to be 1.9. 1020. Yeah, 1.9 into 10 raised to the power of 7 seconds. I hope I am correct. Let me check it in the marking scheme as well. Yeah, 1.9, that is roughly equal to 2.0. 2.0 into 10 raised to the power of 7 seconds. Yeah. Explain why speed is a scalar quantity. Because it only has a magnitude. Because it only has a magnitude. Perfect. Let me write it completely. Because speed only has a magnitude. Speed only has a magnitude. Let's further move ahead. Velocity is a vector quantity. Explain what happens to the velocity of Venus as it orbits around the sun. As Venus orbits around the sun, around the sun, the direction changes, and hence the velocity changes. And hence the velocity changes. Simple as that. There is a resultant force acting on Venus as it orbits around the sun. The force is perpendicular to the direction of motion of Venus. State why this force is needed to keep Venus in a circular orbit. To keep Venus in a circular orbit. Simple as that. Let's further move ahead. Figure 9.1 shows the orbit of Venus around the Sun. Perfect. On figure 9.1, draw an arrow to show the resultant force on Venus. So, how will you show the resultant force on Venus? It will act towards the center like this. It will act towards the center like this. 1 second. It will act towards the center like this. Yep, like this. State what causes the force acting on the Venus. What is the origin of this force? The gravitational field strength of the sun. This force, this force is caused by the gravitational field strength of the sun. By the gravitational field strength of the sun. Of the sun. Simple as that. One planet is in the solar system is closer to the sun than Venus, which is that planet, Mercury. Perfect. Compare the time that this planet takes to complete one orbit of the sun with time TV. Explain this difference. Okay, what will be the orbital period of Mercury compared to the orbital period of Venus? So, how will the orbital period of Mercury compare with the orbital period of Venus? First of all, let's draw it. I think by drawing it, it will get easier. This is Sun, this is Mercury, and let's say this is Venus. Perfect. Can you realize the orbit of Mercury is smaller compared to the orbit of Venus? Can you realize this? Yeah, pretty evident. So this could be your first point. The circumference, the circumference of the orbit of the orbit of Mercury is less. What is the second thing? And Mercury has a greater orbital speed. Why? Has a greater orbital speed due to it due to it experiencing a greater gravitational force due to the sun, or how can you phrase it? And Mercury has a greater orbital speed as it is closer to the sun, as it is closer to the sun. This results in a lesser orbital period for Mercury. So there are two factors that contribute to a lesser orbital period for Mercury. The first one is that you have a lesser circumference. Second is that Mercury has a greater orbital speed. Both of them combine and give you a lesser orbital period for Mercury compared to Venus. Let's further move ahead. In space, an interstellar cloud of dust and gas collapses to form a protostar. The cloud contains hydrogen. Perfect. Describe the energy transfer that takes place as the cloud collapses and forms a protostar. What will be the energy transfer as the cloud collapses and forms a protostar? Your gravitational potential energy, gravitational potential energy gets converted into gets converted into internal energy. Simple as that. As your cloud is collapsing and forming a protostar, gravitational potential energy gets converted into internal energy. Let's further move ahead. The collapse results in a nuclear reaction in the protostar that involves the isotope hydrogen 3. The isotope hydrogen 3 is radioactive. It decays by a beta particle emission. State how the nuclei of isotopes of the same element are different. How the nuclei of isotopes of the same element are different. They have different mass numbers. They have different mass numbers, or if you want to be fancy here, you can say they have different nucleon numbers. Different mass numbers or different nucleon numbers. Perfect. Explain why hydrogen 3 cannot decay by alpha particle emission. Why can hydrogen 3 not decay by alpha particle emission? Because alpha particle emission requires two protons. We have one proton only. So you can say hydrogen 3 has one proton only, and alpha particle emission requires two protons. Simple as that. Let's further move ahead. Now complete the equation for the decay of hydrogen 3 to become an isotope of helium. Okay. If hydrogen 3 is decaying by beta particle emission, what will this be? -1. This will be 0. This mass number will remain same. Proton number will increase by 1 whenever you have a beta particle emission. Explain how the nuclear reaction in the protostar stops further collapse as the protostar becomes a stable star. So in this question, we have to tell how the nuclear reaction in the protostar stops further collapse as the protostar becomes a stable star. So the nuclear reaction in the protostar, the nuclear reaction in the protostar causes what? Causes the temperature to increase. This increase in temperature causes what? Causes an outward force. Causes an outward force. As this as this outward force balances the inward gravitational force, balances the inward gravitational force, gravitational force, the star becomes stable. The star becomes stable. Simple as that. Let's further move ahead. The cloud and dust that collapses also contains atoms of the heaviest element. By this only I know what is going to be asked about. Supernova. Always remember, heaviest elements are formed in the supernova. State which part of the life cycle of a star is responsible for the production of the heaviest elements. Supernova. Let's further move ahead. Table 8.1 shows data about three planets Mercury, Venus, and Earth. Perfect. So these are data about three planets Mercury, Venus, and Earth. Perfect. Figure 8.1 shows these planets in alignment with the Sun. They rotate around the Sun in the direction shown. Mark and label in figure 8.1 the positions of these three planets 110 days after the position shown in figure 8.1. Okay. So currently this is the position of Mercury, Venus and Earth. We have to mark the position after 110 days. Okay. So what will we do? First of all, let's consider Mercury. Let's consider Mercury. Mercury takes 88 days to complete one orbit, or you can say Mercury takes 88 days to complete 360-degree rotation. How many degrees will Mercury rotate in 110 days? Apply ratio method. X is equals to 110 into 360 divided by 88. This comes out to be 450 degrees. So in 110 days, Mercury will rotate by 450 degrees. Okay. Where will 450 degrees be? This one entire rotation will be 360 degrees. And 360, or you can say, or you can say, oh, what have I done here? 88, this is 110. Okay. 450 minus 360 will be equal to what? 90 degrees. So, after 110 days, Mercury will be here. After 110 days, Mercury will be here. Make sure you draw with a compass or at least draw with a good drawing, at least, not like me. Secondly, you have what? Venus. Okay. Venus takes 2 to 220 days to cover an entire orbit, or you can say 360 degrees. In 110 days, how many degrees will Venus cover? X is equals to 180 degrees. So if Venus moves by 180 degrees, where will Venus end up? Somewhere here. And make sure this is bigger than the Mercury, just as the diagram initially depicts. Now let's come on to Earth. Let's come on to Earth. Let's choose a good color for Earth. Let's take pink. Yeah. Okay. So Earth takes 365 days. Let's write it here. Earth basically takes 365 days to cover how many degrees? 360 degrees. 110 days will cover how many degrees? X. Can you calculate the value of X? Yes. X is equals to 360 into 110 divided by 365. What is the value of X? Let's calculate that. Let's calculate that. 360 into 110 divided by 365. Your answer comes out to be 108. 108 degrees. So Earth will be somewhere between 90 and 180. and it will be bigger than Venus and Mercury both. This is how your diagram will look like. Let's further move ahead. Each of these three planets has a similar average density. Explain why the gravitational field strength at the surface of Mercury is much smaller than that at the surface of Venus. Why is the gravitational field strength of Mercury less than the gravitational field strength of Venus? Why? You can say because Mercury has a smaller mass. You can say because Mercury has a smaller mass. Simple as that. Let's further move ahead. An object has a weight of 37 Newton on the surface of Mercury. Perfect. What is the gravitational field strength on Mercury? 3.7. Okay. Can I calculate the mass using these? Yes. W is equals to mg. Weight is 37. M into 3.7. Your mass comes out to be what? 37 divided by 3.7. This is equals to 10 kg. 10 kg is your mass. You have to calculate the weight on the surface of the earth. Weight is equals to mg. Mass is 10. What is the gravitational field strength? What is the gravitational field strength? 9.8 on earth. Multiply it. 10 multiplied by 9.8. This gives you a value of 98 Newton. State what is meant by a moon. A natural object or a natural satellite. A natural object that orbits around a planet, orbits around a planet, or you can say around Earth. Simple. The sun will eventually run out of hydrogen. Describe what happens to the sun when hydrogen runs out. The sun expands and becomes a red giant star. Becomes a red giant star. Perfect. Later, it gets converted into planetary nebula, planetary nebula, and after energy losses, it converts it converts into a white dwarf. Simple as that, nothing complicated. Let's see the marking scheme as well. Yeah, simple. Let's see this. Figure 8.1 is a picture of a nebula formed from a supernova. Very good. State what is meant by a supernova. Explosion. Explosion as the hydrogen in the red supergiant runs out. You can say as the, or you can say explosion as the hydrogen, as the hydrogen in red supergiant runs out. Red supergiant runs out. Simple as that. Describe how a protostar forms inside a nebula. So, what will you say? What will you say here? How a protostar forms from a nebula? You will say cloud of dust and gas comes together. Comes together due to gravitational pull or gravitational force of attraction. They collapse due to gravitational force. They collapse and cause an increase in temperature. And cause an increase in temperature. Increase in temperature. Simple as that. Nothing complicated. Let's further move ahead. Our sun is in circular orbit around a black hole at the center of our galaxy. State the name of the galaxy that contains our sun. Milky Way. Milky Way. State what is meant by light year. Light year is the distance traveled by light in 1 year. Distance traveled by light in 1 year. Simple as that. Let's further move ahead. The time taken for one complete orbit of our sun around the black hole is this. Okay. Let's suppose this is a black hole, and let's say the sun is orbiting like this around the black hole. Perfect, perfect, perfect. So this is your time period. Okay. The distance from our sun to the black hole is 26,000 light years. So this distance is what? 26,000 light years. Perfect. 1 year has this many seconds and the speed of light is this. Calculate the speed of the sun as it orbits around the black hole. Show your working and give your answers in meters per second. So you have to calculate what? Orbital speed. Orbital speed is equals to 2 pi r divided by the time period. Now what will be the r here? 26,000 light years. But how will you calculate the distance in 1 light year? The distance in 1 light year is very easy to calculate. Speed of light multiplied by the amount of seconds in an year. So the speed of light is 3 into 10 raised to the power of 8 multiplied by 3.2 into 10 raised to the power of 7 divided by the time period, that is 7.3 into 10 raised to the power of 15. Let me zoom in a bit and tell you again what have I done here. So I have to calculate the orbital speed of sun. 2 pi r. What is r here? R is 26,000 light years. So I took this 26,000, multiplied it by the speed of light, and then multiplied it by the amount of seconds in 1 year to calculate the distance between the black hole and the sun. Can you calculate the orbital speed here? Yes, very, very easy. The orbital speed comes out to be 210,100,000 meters per second. Simple as that. Let's further move ahead. Okay, let's see this. The Earth has a radius of 6.4 into 10 raised to the power of 6 meters and rotate on its axis once in every 24 hours. Okay. Figure 9.1 shows that as the Earth rotates, objects on the surface of the Earth move in circular paths around the axis of rotation. Perfect. Calculate the speed of an object at the equator as it moves in a circular path around the axis of rotation. We have to calculate the speed of the object. So again, orbital speed formula 2 pi r over time period t. What is r here? R is 6.4 into 10 raised to the power of 6. 6.4 into 10 raised to the power of 6. What is the time period? 24 hours. 24 into 60 minutes in each hour into 60 seconds in each minute. Can you calculate the orbital speed here? 2 pi into 6.4 into 10 raised to the power of 6 divided by what? 24 into 3600. Your answer comes out to be 465 ms minus 1. Let's further move ahead. Explain why the speed around the axis of rotation of an object on the earth decreases as the distance of the object from the equator decreases. So let's say now your distance from the equator is decreasing. Let's say you are at this point. Let's say you are at this point B. If your distance from the equator decreases, what happens? Your radius decreases. Your radius around the sun decreases. As your radius around the sun decreases, your velocity will decrease. So you can write it here as radius of orbit decreases while keeping the time period constant, while keeping what constant? This time period t constant, while keeping time period t constant. This causes the speed to decrease. This causes the speed to decrease. Simple as that, nothing complicated. The earth moves around the sun because a force acts on the earth. State what provides this force. The gravitational field strength of the sun. The gravitational field strength of sun. Simple as that. Let's further move ahead. The orbit of the earth around the sun is an ellipse. Perfect. Describe what happens to the magnitude of the force that acts on the earth as it moves in its elliptical orbit. So, how does an elliptical orbit look like? Let's say this is your sun, and your earth will move in an elliptical orbit like this. Let's say this is your earth. So, the points where the earth is closer to the sun, let's say point A, the earth will experience a greater force. The points where earth is away from the sun, it will experience a lesser force. So you can write it here. State what happens to the magnitude of the force that acts on the earth as it moves in this elliptical orbit. The magnitude of force changes. Magnitude of force changes. As earth comes near to the sun, near to the sun, force increases, force increases, and as earth moves away from the sun, away from the sun, force decreases. Away from the sun, force decreases. Simple as that, nothing complicated. Explain why the earth travels the slowest when it is at the furthest distance from the sun. If the earth is at the furthest distance from the sun, what will happen? Gravitational potential energy will be maximum, kinetic energy will be minimum, hence velocity is minimum. So you can write it here. When the earth is furthest away from the sun, gravitational potential energy is maximum, kinetic energy is minimum, hence velocity will be minimum. Hence velocity will be minimum. Simple as that. This marks the end of space physics past papers. If you have any question, you may ask in the chat.